everyone. Today I am going to talk about the Harmonic Oscillator. First, the energy expression of Harmonic Oscillator is epsilon V plus half omega bar oscillation minus V plus half square omega bar oscillation into x centimeter inverse, where x is the enharmonicity constant. In case of Harmonic Oscillator, when V value increases, the energy difference between the transition level decreases. That we can observe in the diagram. As the V value increases, the difference in the energy levels is decreases. So what are the selection rules? Selection rule for enharmonic oscillator is delta V equal to plus minus 1. It can be plus minus 2 or it can be plus minus 3. That means the transition can take place from 0 to 1, 0 to 2 or directly from 0 to 3 and so on. The transition that takes place from 0 to 1 level is known as our fundamental transition. The transition takes place from 0 to 2 level, that is known as our first overtone. The transition that takes place from 0 to 3 level is known as our second overtone. Then we can find the energy difference between these transitions. So suppose in case of fundamental absorption, what will be the energy difference? For energy difference, we have to find out delta E equal to epsilon. Suppose we are taking from transition from 0 to 1. So subtract the lower level from the higher level. The epsilon 1 minus epsilon 0. Now here replace the energy expression in case of epsilon 1, the V value by 1, and in case of epsilon 0, replace the V value by 0. Put the 1 for epsilon 1 in place of V and put the 0 for epsilon 0 in place of V. So by doing this calculation, we can obtain the final expression as omega bar oscillation into 1 minus twice x centimeter inverse. Similarly, we can find out the energy difference for the transition from 0 to 2 level. Here again we replace the V value by 2 and 0. By doing the calculation, we obtain that the energy difference is twice omega bar oscillation into 1 minus twice x centimeter inverse. So this is for first overtone. Now in the third case, we obtain the energy difference for 0 to 3 level transitions is thrice omega bar oscillation 1 minus 4x centimeter inverse. So this is for second overtone. Now the next transition is that takes place from the higher levels. That means from level 1 to level 2 and level 2 to level 3. This type of transition is not going to take place from the 0 level. So they are known as hot bands. The transitions that takes place from the higher level except the 0 level are known as the hot bands. So let's find out the energy difference for hot bands. Here we have calculated the energy difference for the transition from 1 to 2 level. So we subtract epsilon 2 minus epsilon 1. Here we obtain the expression omega bar oscillation into 1 minus 4x centimeter inverse. So hot bands can be observed as a weak absorption band and near about the fundamental absorption bands. Suppose we take the two temperature T1 and T2. Suppose T1 is lower than the temperature T2. So how is the intensity of the fundamental and hot bands look like? At lower temperature, we found that the intensity of hot band is very small compared to the fundamental band, Whereas at higher temperature, the intensity of the hot band is found to be near about equal as compared to the fundamental band. This might be due to the reason that most of the time at room temperature, the population remains at the ground level. So when we talk about the transitions, then the most of at room temperature, the transitions are very likely to take place from 0 level to 1 level. But at one level, there is a very least amount of population at room temperature. So the intensity that is going to be observed for the transition 1 to 2 is found to be very less. But if we increase the temperature, of the sample, then population inversion is going to be takes place. The population that is present at the ground level is now moved to the higher level. So we can observe the intensity of the higher level also when we increase the temperature of the system. So the bands that is observed by increasing the temperature of the system is known as hot bands. So that's all for today. Thank you.